In this video, I will walk you through configuring a connection to an Omni Flow computer using the TOPServer, which are common in the oil and gas industry for electronic flow measurement, or EFM, throughout the various stages of collection, distribution, and transport of oil and gas. I will cover the channel and device setup, including EFM settings, give a summary of the settings that will be encountered, and when it is appropriate to change them from the default values. So here in my TOPServer configuration, the first step in configuring a connection to an Omni Flow computer from TOPServer is to create a channel. A channel represents a communication link from the PC running TOPServer to the device. In the case of the Omni Flow computer driver, the channel can represent the serial port when using serial devices, or the socket connection over which Ethernet communications will occur. Here we need to, so I'm going to go ahead and click to add a channel. And here in the type of channel to be created, I select my driver, and we need to select the Omni Flow Computer driver. So there's Omni Flow Computer in my list. And then I'm going to go ahead and click Next. Now the channel name is configurable and will be how the channel appears in the TOPServer tree view, and is also how clients will reference devices configured under this channel. For demo purposes, I will simply call my channel Omni_Flow. And I'm going to go and click Next. Here's where I choose whether or not this channel should be included in a virtual network. And if I set this to use a virtual network, which virtual network the channel should be assigned to. The transactions per cycle specifies the number of single read-write transactions that can occur on the channel. When a channel is given the opportunity to communicate, this number of transactions is attempted. For the purposes of this demo, though, we're going to go ahead and leave virtual network set to none and click Next. Now we need to select the appropriate connection type for this device. I'm going to expand this so we can see all the settings in the same frame. Now, if I'm using a serial connection, I would leave this set to COM port, and the serial port settings such as baud rate, parity, etc. must be set to match those of the actual device. If Internet encapsulating the traffic, which is what we're going to be doing here, I'm going to select Ethernet encapsulation. This is where we specify the network, which network adapter the TOPServer should use for communications. Now, for the purposes of this demo, like I said, we're going to select Ethernet encapsulation, and I'm going to leave my network adapter at default, which allows the operating system to select the appropriate NIC to use based on the device's IP address, which will be specified later in the device properties. I'm going to go ahead and click Next, and here's where we configure the connection behavior. The close idle connection setting will terminate the connection when it is not in use for the specified number of seconds, when it's enabled, which it is by default. When enabled, the idle time to close setting defines how long the period of disuse is before the driver should terminate the connection. Which is the default is 15 seconds. So after 15 seconds of idle, the driver will close the connection. For the purposes of this demo, we're just going to leave both of these settings at the default. We'll go ahead and click Next. Now here's where we review the write optimization settings for this channel. And that determines the optimal method of writes based on the write queue and the property of write operations to read operations. So the determines whether writes have a higher priority compared to reads or not. Now these will generally be left at the default value. They can be altered as needed if you in particular have a lot of writes that you're doing. Then this duty cycle can have an effect on your read performance if you're doing a lot of writes. For instance, this by default you've got a duty cycle of 10. Which is one read for every 10 writes. So we're heavily weighting write priority with the default setting. So if you're in a situation where you're doing a lot of writes and you see any issues with read performance and you need to balance that out, you can reduce that duty cycle to lower the priority on writes and give your reads a little bit of an additional higher priority. Like I said, we're going to keep the default here. And go ahead and click Next. And here's where we review how the driver will handle non-normalized floating point values. This can generally be left at the default value unless non-normalized values are expected from your device, such as not a number or infinity for floating point values. We're going to leave that at the default and go ahead and click Next. Here, an inter-device delay can be configured if you want to. It's disabled by default with a value of 0. This setting determines whether the channel will pause after receiving data from a device before switching to the next device on the channel. It also assumes you have more than one device configured on a channel. For Ethernet communications, our general recommendation is that you have one device per channel for the best communication, unless you're in a telemetry situation where a lot of times that's not possible and you do have to have multiple devices on the channel. So if you're using an inter-device delay, this setting specifies how many milliseconds that inter-device delay pause should be. Like I said, this setting can be particularly useful in telemetry scenarios if your radio requires time between requests. For this demo, we're going to go ahead and leave the inter-device delay set at 0 or disabled, and we're going to go ahead and click Next. And as you can see, this last dialog summarizes the selected channel settings that we've just gone through. Now, it also applies the ability to tweak the settings here in the summary if you happen to notice that there's something incorrect. Now, you'll notice that my name here and the physical medium are bold. Anything bolded in this summary indicates a change from the default values. All our settings are correct, so I'm going to go ahead and click Finish to finalize the configuration and create the channel. You'll see that I added my Omni_Flow channel. Now that the channel is complete, we need to add a new device to the channel. So I'm just going to go ahead and click this, click here on this, click the Add Device option under my channel. And as with the channel name, the device name is user configurable, and it's how this device is going to appear in the TOPServer tree view, and it's going to be part of how a client application accesses this device. Now, for the demo, I'm going to call this FC1 for Flow Computer 1. And then I'm going to go ahead and click Next. Now, here we select the device model, and that's going to be based on, if I open this drop down, you'll see there's an Omni gas firmware and there's an Omni liquid firmware. So which one of these we select depends on whether your Omni Flow computer to be communicated with has gas or liquid firmware loaded on it. For this demo, I'm going to go ahead and leave the default of gas firmware. You'll want to confirm which firmware is loaded on your particular Omni Flow computer, and you'll want to select this device model to match that. So we'll keep the default of gas firmware, and you'll notice I will mention in some sections as we go forward if there is a difference. I will point out that if you'd selected liquid firmware, there may be an additional section, and I'll point out what that would need to be configured for. So let's go ahead and click Next to proceed. And here we specify the device ID of the Omni Flow computer itself. Now, you'll want to confirm in your configuration software for your Omni Flow what device ID it is currently configured for, and make sure to enter that to match here. Now, that's including you can specify an ID format of octal, decimal, or hex. So you want to make sure that what format that number is that you got from the configuration software to make sure that what you're entering here is going to match exactly. Otherwise, you'll have communications issues because that device won't recognize that you're asking to speak with it because the device ID won't be correct. For our purposes, we're going to keep an ID format of decimal and an actual ID value of 1. We're going to go ahead and click Next. Now we need to specify the device's scan mode settings for subscription-based clients. In systems where bandwidth utilization is not a concern, this setting should really be left at the default, which is respect client-specified scan rate. Now, client-specified scan rate applies mainly to OPC-type clients, whether it's OPC UA or OPC DA, whereas with client interfaces like DDE or SweetLink, a lot of times we're specifying that scan rate via the alias map in TOPServer. This default simply respects the requested scan rate from the client application to determine how often to actually go out and poll the device. Now that's for real-time data that we're talking about with these polling. Any EFM data collection is going to be controlled by the EFM exporter plugin. And that's actually going to be covered in a separate video. That's beyond the scope of this particular video. Just be aware this scan mode only affects real-time data collection from your Omni Flow computer device. Now, as far as the other scan mode options, Request data no faster than, that's going to set a scan rate ceiling. So basically data will be requested no faster than the specified time frequency. The request all data at means all data will be requested at the specified timing frequency. So it's basically a flat scan rate. No data is ever going to be requested faster than or slower than the rate that's specified. Then you've got a do not scan demand poll only. That means there will be no automatic scanning done of the device unless a plugin or a client application actually manually triggers the poll. And there's an underscore demand poll system tag that will exist for each device that allows a client application to actually manually trigger a poll to the device for real-time data. And last but not least, the respect tag specified scan rate. When set to this, that's actually going to respect the scan rate that's specified at the tag level. And that's when you're actually when you're defining static tags in your TOPServer configuration for a device. There's a scan rate that you can specify at the tag level. So when you set this rate, it's actually going to poll the device for each tag based on its own individual scan rate that's specified if you define a static tag database. So like I said, for our purposes, we're going to go ahead and leave that scan mode at the default, and we're going to click Next. Now we need to specify the actual IP address, port, and whether the connection should use TCP, IP, or UDP for the transport. So here I'm going to enter an IP address of 192.168.111.50, and we're going to keep the default port of 2101. However, you should check your device and the configuration software to determine the specific port number that it's actually configured to use, and you'll want to enter that here to match. For the transport, you'll see we support UDP or TCP IP for Ethernet encapsulation. I'm going to leave that to default of TCP IP, and we're going to go ahead and click Next. Now here the timing settings should be set appropriately based on the type of connection and the level of congestion on the network. I'm just going to expand this so we can see everything at the same time without having to scroll. Now these can generally be left at the default just to get started until you establish communications, and then you can either increase or decrease these as needed based on whether you're seeing some timeout waiting for response in the TOPServer event log and things of that nature. But, for instance, if you're seeing a lot of connection timeouts to the device, you may want to increase your connect timeout to give the device more time to accept the socket connection from TOPServer. If you're actually getting connected to the device, but you're seeing a lot of timeout waiting for response, like I said, in the event log, you may need to increase the request timeout to give the device more time to respond before TOPServer times out waiting for that response. Essentially, the goal is to have the timing settings as low as possible while still maintaining successful communications. This allows the driver to detect actual communications issues more quickly. Now, you can also specify the number of request attempts that TOPServer should try before it actually completely times out and moves on to the next device. That defaults to 3, which is normally a good number of timeouts just to get started. Like I said, you can go back and tweak those later if you find that you have a device that's particularly unresponsive and you don't want to try it as many times. You can lower the number of attempts on that one. Here you can also specify an inter-request delay, and that's going to insert a delay between requests to this specific device. That's different than an inter-device delay, which is between devices. This is an actual delay between the requests to the same device. This can be useful for slower devices where it's necessary to give the device more time between requests to prevent overloading the device. Like I said, for our purposes, we're going to maintain these defaults and go click Next. The auto demotion settings determine whether unresponsive devices will be taken out of the polling cycle for a specified period of time. In situations where multiple devices are configured under a single channel, which is normally going to be the case, like I said previously, in telemetry or sometimes in multi-drop serial scenarios, it's recommended to enable auto demotion in those scenarios, and so I'll show you what that looks like. You'll enable that. It is recommended to discard write requests during that period. Otherwise, write request will override the auto demotion period and attempt a connection to that unresponsive device immediately. Now, since devices under a channel are treated sequentially, Having auto demotion enabled will prevent a down device from repeatedly slowing down your communication for the other devices over and over again. Once you enable that, you specify how many timeout cycles from those previous timing settings to go through before it pulls the device out of the scan cycle and demotes it. And then once it's demoted, this demotion period determines how long it's going to be demoted for before the driver will actually attempt the connection again. For our purposes, since we're only going to have the one device on the channel, we're going to go ahead and set that back to the default of disabled, and we're going to click Next to proceed. Now we specify the time zone that the device resides in, and whether the device time should be synchronized with the system time of the machine that TOPServer is running on, and also whether or not to respect daylight savings time. This depends on whether your device is respecting daylight savings time or not. Now, the possible time synchronization settings are, and it's disabled by default. That means, and when it's disabled, the timestamp of the device is never going to be synchronized with the TOPServer system clock. The device's timestamp and date timestamp will stay at whatever they are and won't get synced with TOPServer's timestamp. Now, the absolute method, with that method, the timestamp of the device will be synchronized once per day at a specified time. So if I select that, you'll see I can specify an absolute time. So by default, it defaults to midnight. So if I left this at absolute, and if I let this at the defaults for absolute, then I would do a time sync every day at midnight. Now, there's also the interval time sync method, and the timestamp of the device will be synchronized on startup and then also at the specified time interval. So by default, if you set this to interval, then we're going to do a time sync at the beginning when we first start up and connect to the device, and then every 60 minutes after that. Then there's also the on-poll method, and the timestamp of the device will be synchronized only when an EFM poll for the device is completed. So basically, every time TOPServer is doing an EFM poll, we're also going to be doing a time sync at that same time. So the time synchronization settings are intended to prevent the device clock from drifting too far from the TOPServer system clock, and it's primarily going to affect EFM record polls, not real-time data collection. Now, for all methods, you'll notice this time sync threshold setting, which when it's 0, it's disabled, but when it's set to a non-zero value, this allows the driver to compare the device and system times, and when the difference is greater than the value that's specified for the time sync threshold, it's going to perform a time sync. This ensures the drifting of the device's clock is never greater than a defined amount. For this demo, though, we're going to specify absolute, so I'm going to set this back to absolute, and then we're going to keep the default time of midnight. We're going to go ahead and click Next. As you may or may not be aware, Omni Flow communications are based on Modbus, the Modbus protocol. So here we specify some protocol and device-specific settings pertaining to addressing and data orders in Modbus that allow TOPServer to work with different implementations of the protocol on different Omni Flow devices, depending on how the protocol has been implemented. So I'm just going to expand to this so we don't have to scroll. We can see everything on one screen. So to start with, for the zero-based bit addressing setting, this denotes that bits within registers are addressed from 0 to 15 when it's enabled, which is the default. Now, if your OmniFlow requires addressing bits within registers as 1 to 16 instead, then you'll just need to disable this setting. We're going to keep the default of enable. Now, the next section, Modbus function code 6 setting, this indicates that the driver will use Modbus function code 6 when writing to single registers when it's enabled, which is the default and what we're going to be using. Now, if you know your Omni Flow computer requires Modbus function code 16 for single and multiple register writes, then you'll just want to disable this setting. Similar thing here with Modbus function 5. This indicates the driver will use Modbus function 5 when it's writing to single coils when it's enabled, which again, that's the default and it's what we're going to be using. If you know your Omni Flow computer requires Modbus function code 15 for both single and multiple coil writes, then you'll want to disable this setting. And there's also a device password field here that allows you to enter the corresponding password for communications with your Omni Flow if it has been configured to require a password. Otherwise, and for our purposes as well, you want to leave the password blank if a password is not required by your Omni Flow computer. And moving on, we get to the Modicon bit order, which is disabled by default. This setting allows the bit order on reads and writes to registers to be reversed to follow the bit ordering of the Modicon ModSoft programming software when it's set to enable. Like I said, though, the default is disabled, which is what we're going to maintain, and that results in bit 15 or 16 being the most significant, depending on the bit addressing setting that we specified up here, 0 or 1 base. And the last setting in this section is use Modicon mode, which affects how register addressing is treated and allows the driver to be compatible with any Omni Flow computers that have been configured to use Modicon compatible conventions when this is set to enable. Now, if we set this to enable, that would mean that registers are offset by -1 for real-time and EFM communications. It also means that 32-bit registers for real-time reads and writes are treated as two 16-bit registers. And for 64-bit registers for real-time reads and writes, those will be treated as 4 16-bit registers. Also, when this is enabled, words are going to be swapped for floats on real-time and EFM communications. However, like I said, the default is disabled, which is what most Omni Flow computers are going to require and what we're going to use here. So we'll go ahead and click Next. Now we can specify the block sizes the driver should use for both Boolean and numeric or register variables, both of which default to a block size of 32, as you can see. Block sizes allow you to maximize the amount of data that can be returned in a single response. However, it is important to remember that sometimes larger packets can be problematic for spotty telemetry type networks, and smaller packets can actually be more reliable in those scenarios. The Boolean block size support can go up to 2,000 in multiples of 8, so like 32, then I could go to 40, I could go to 48, I could go to 56, so on and so forth. So that you can max that out at 2,000. And for the numeric variables block size, that supports up to 125 per the Modbus specification. Now, it is recommended to use the defaults until successful communication is established, and then you can increase the block sizes as needed, with the ideal being the largest block size you can specify while still maintaining reliable communications without errors in the TOPServer event log. So like I said, we're going to keep the defaults and go ahead and click Next. Now here, since we're using Ethernet encapsulation for our connection, we need to specify whether the OmniFlow is using Modbus TCP protocol framing or not. Now typically Modbus TCP framing is not in use, and it is purely Modbus serial encapsulated by standard TCP wrappers. So the default of disable here is recommended, and it's what we're going to use. Unless you know for sure that your OmniFlow is using Modbus TCP framing specifically, you should leave this disabled. And the deactivate tags on exception setting, when that's set to enabled, which is the default, that tells the driver to stop polling for a block of addresses if the device ever responds with a Modbus exception code 2 or 3 when the block is requested. Now this is designed to make the driver more efficient by preventing continued requests for non-existent addresses in your device. Now if you have a situation where some addresses may only be available part of the time and you need those addresses not to be deactivated, then you'll want to set this to disabled. For our purposes, we're going to maintain the default and click Next. Here we need to specify some settings specific to EFM collection from the OmniFlow. So I'm going to expand this again so that we have everything on the same page as much as I can here. And as you can see here, we've got a non-meter alarms and events setting. This defines where the driver should store non-meter specific alarms and events when they're uploaded from an OmniFlow computer. The default is storing these for meter 1 only, as you can see. If I expand this list, you'll see it's possible to store those for any other single meter. This driver supports up to 4 meters total for a single OmniFlow computer. Or you can have non-meter specific data sent to all meters, stored for all meters, or you can also ignore non-meter specific alarms and events. We're going to keep the default of meter 1 for that. And then we get to the archive access method, which this determines which method will be used by the driver to access the archives. With method 1, you see we have a choice between method 1 or method 2. Method 1 is the older legacy method, and method 2 is the default because it's a more efficient method. Now, so it's always going to be recommended to keep the default of method 2, which is what we're going to do here, unless you have an older Omni Flow and you know specifically that it actually requires method 1 in order for you to achieve archive access. So next we've got the clear cache setting. That controls clearing the driver's EFM cache, which stores history, alarms, and events data for each meter. This setting can be toggled to yes, which will result in the cache being cleared on the next EFM upload, which causes the driver to retrieve all available EFM data from the Omni Flow, even if it's been previously uploaded. Once complete, the setting toggles back to no. Now, since we're in the initial configuration stage, we can leave this at the default. Some use cases for clearing the cache: if for some reason upstream from TOPServer, maybe the export file somehow got corrupted, lost, or misplaced, something of that nature, and you need to recollect and relog all of that data from your Omni Flow computer, you could clear the cache and have all that data get repulled again. So that's one use case. Also during testing, things of that nature, if you need to clear the cache and repull everything. That clear cache allows you to do that. So now we get to the shared hourly archive number setting, and that defines which device archive number is shared by each meter for shared hourly data. This defaults to 0, which means this functionality is disabled. If this is set to 0, that means it's disabled. Actually, it defaults to a value 5. So we're going to leave that at the default. You'll want to make sure in your Omni Flow computer what archive is set up for shared hourly data, and you want to make sure that you actually specify that particular number here in order to match up with what's configured in your device. Now, move on. There's also a similar setting for shared daily data, so shared daily archive number. And that defines which device archive number is shared by each meter for shared daily data. Now this one actually does default to 0. I misspoke earlier on the other one. This one actually does default to 0, which means shared hourly data actually, shared daily data actually is disabled by default. If your Omni Flow is configured with an archive for shared daily data, you need to retrieve it during EFM polls. You want to make sure that this setting matches up with the proper archive number that's actually configured in your device for daily data, shared daily data. And though it's not visible here because we're using a gas firmware model, if you were using a liquid firmware model, you actually would also have a shared batch archive number setting just beneath the daily archive number setting. And that's for liquid models for shared batch data between liquid meters. Now, it defaults when you're using a liquid firmware model, it defaults to a value of 0, which is disabled. Again, like with the other two archives, you want to confirm in your configuration software for your Omni Flow what batch archive number set up for that shared batch data, and you'll want to make sure that your setting in TOPServer corresponds to that. And then we get down to the config address setting, and that specifies which address in the Omni Flow corresponds to the group configuration address for archive 1. The default, which we are going to use, is 13,500, which is typically the correct setting for most Omni Flow computers. Only change this if you know for sure this has been set differently in your Omni Flow computer. Then we get to the max record address setting, and that specifies the address in the Omni Flow which retains the value of the maximum number of records for archive 1 in your Omni Flow computer. As before, we're going to be using the default, which is 3701, which is typically the correct setting and should only change if you know that this is configured differently in your Omni Flow. Now, the last setting in this section is the date format address, and that specifies which address in your Omni Flow has the date format stored to use for all archive data. Again, we're going to be using the default of 3842, which is normally correct, and again, that should only change if you know it needs to be different based on your Omni Flow's configuration. But let's go ahead and click Next to proceed. And we get to our device summary. Here we can review the device settings in the summary for correctness, as we did with the channel, and make any necessary tweaks in case we see something that we missed that needs to be different. Again, you'll notice my name, my IP address, and my time sync method are all in bold because those are settings that we change from the defaults. So I'm going to go ahead and click Finish creating my device. You see there's my device created under my channel. You'll now notice 2 additional configuration sections in the tree view under our new Omni Flow device for the EFM mappings and the actual EFM meters in the Omni Flow computer. So if I highlight the mapping, I'm going to expand EFM mappings. If I highlight mapping here, you can see there are a number of pre-configured alarms already mapped for some of the common alarms. Now, if I take one of these and I double click on it to open its properties, and you see there's not much to configure under the general section, just the name. If I go into the configuration section though, you can see an EFM alarm is composed of the actual address in the Omni Flow that corresponds to the alarm. And you got the type of alarm it is, such as alarm on temperature, differential pressure, static pressure. Expand that, you can see a backflow, cutoff, battery, and then you've got the state setting, which is going to be whether that's going to be the state of whether it's an alarm, and that's going to be on, off, high, or low as the options for the state that's generating the alarm. Any alarms in your Omni Flow computer that are, I'm going to cancel this, any alarms in your Omni Flow computer that are not part of these pre-configured alarms will need to be added with the appropriate settings, appropriate 3 settings that we just saw. Otherwise, they'll be treated as non-meter specific data, and they'll get stored according to the setting that we defined in the device properties, which they'll get stored in meter 1, because that's what we left. That's the default setting. We used that. So any non-meter specific data like alarms that aren't defined here would be stored to meter 1. And you'll have noticed there's an N specified in the alarm address. That N designation in the address is variable and denotes the number of the meter run. And that allows an alarm to be treated appropriately depending on the meter it came from, keeping you from having to define one of these for each meter. You can define one of these, and these will be used for all of the meters that are actually configured. Now, to add a new alarm, you simply right-click on the mapping group, select New Alarm, and then under the configuration setting, you'd specify the corresponding address, the type, and the state as we just discussed. Now, the mappings group itself, if I go there and I double-click on that, you'll see there are some properties associated with that mapping group itself, and contains EFM-specific attribute mappings, and that's going to be for hourly and daily history data in the Omni Flow. And also, if we were configuring an Omni Flow with liquid firmware, you'd also have a 3rd section down here for batch data as well. Now, if an attribute is left blank in one of these for hourly or daily history data, it will be ignored by the driver. The proper syntax for one of these attributes contains the index offset for that attribute in the EFM record as configured in your Omni Flow. And it's possible to use several modifiers, such as a /. You'll see the flow time here actually has it's using an offset index of 0, and then a / and a value of 120. That applies scaling to the actual value from the record. So it'll take whatever value it gets from index 0, divide it by 120 to apply scale to that record. Another one you can do is you can specify an exclamation point before a value that you define in here, and that will make that value a static value. It means it will use that value when your EFM data is being exported. So it's not actually going to pull data from a record. It's going to use that static value when you define an exclamation point in front of it. It's even possible to specify a prefix of S on these. So like I could do for differential pressure, I could do like an S in front of that. And if you do that, if you wish to specify that the value comes from the shared archive, per the shared archive settings that we configured earlier in the device properties. So this particular one would have been the shared hourly archive. That would pull from that shared archive. Specific details on acceptable syntax for these indexes is available in the Omni Flow Computer driver help file. So I can actually launch that directly from here, and it takes me directly to that setting. There's EFM mapping for the liquid model. It's going to show you all the proper syntax that you can use, all of the attributes that are available, and the syntax that you can use for these. And there's also a section for the gas model, which is what we're doing. But we're going to go ahead and close that. I'm going to maintain the defaults on all these, so I'm going to click cancel. And now we're going to move on to the actual EFM meters themselves. So down here, the Omni Flow Computers as a driver, as I mentioned earlier, supports up to 4 meters per flow computer, and that's going to be true whether you're doing gas or liquid firmware from those models chosen earlier. Now I'm going to expand that. You'll see you got meter underscore 1, 2, 3, and 4, and only meter underscore 1 is enabled by default. So if I double click on meter 1 to open the properties, the meter name itself is just a user configurable descriptive name for the meter. We're going to leave that set to meter underscore 1. You can also define an optional description if you want to provide further information about this specific meter. And the driver is just a read-only field, like you can't make any changes to that. And that just shows the driver that's associated with this particular meter. Now when we move on to the configuration section, you'll see the hourly archive number defaults to 1, but this must match what is configured in your actual flow computer. That also means that hourly archive number, when it's set to a non-zero value, means that's actually enabled, and we'll retrieve that data, assuming that number that's specified is correct. Otherwise, you'll get some errors if that's not the correct number. Now, you can also see that the daily archive number is disabled because it's set to 0. So if you do have daily historical data that you wish to collect from meter 1 in your Omni Flow computer, you would need to set the daily archive number here to the appropriate daily archive number to match your device. So we're going to keep the defaults there. For the other 3 meters, if I open one of these, go to the configuration, you'll see both of those are set to 0. Same thing in meter 3. Both of those are set to 0. Meter 4, both of those are set to 0. That just means that meters 2 through 3 are disabled out of the gate, and you would need to go into those and specify the appropriate archive numbers for any of those other meters configured in your Omni Flow computer that you need to collect EFM data from. So lastly, if I go back up here and I highlight my FC1 device, lastly, static tags can now be configured in the server for real-time data collection from the Omni Flow, if you desire to do that. A lot of our users prefer not to have a static tag database in their TOPServer project, and they choose to dynamically specify real-time addresses from the client application under the configured device. Now, for help with the proper addressing syntax, click here. You can go to the driver, or you can go to the Omni Flow Computer driver help file. Under the address description setting, that's going to give you all the details about proper syntax for all of the different types of real-time addresses that you can access with the Omni Flow Computer driver. So, in closing, this video has shown the general steps required for quickly configuring an Omni Flow computer in TOPServer version 6 for EFM and real-time data collection. It is not intended to be a comprehensive how-to regarding the Omni Flow computer driver and the TOPServer Omni Flow computer driver help file that you've seen a couple of times in the video should be referenced for further, more detailed information on some of the settings. While EFM meters were set up in this video, the TOPServer EFM exporter plugin help documentation should be referenced to set up scheduled EFM polling and exporting to the desired EFM format.